Hey you're on a rock floating in space, surrounded by a whole lot of nothing. Well, mostly nothing. There's also gas, stars, black holes, and oh yeah, you. But here's the thing. If you zoom in far enough, past the cells, past the atoms, past the protons and neutrons, you'll find something pretty weird. Everything you know, everything you see, might actually be made of tiny vibrating strings. Welcome to string theory. All right, let's back up for a second. We have a bit of a problem in physics. Two problems, actually. On one hand, we have general relativity, which is great for explaining how really big things, like planets, stars, and galaxies, move and interact. On the other hand, we have quantum mechanics, which is great for explaining how really small things, like electrons, quarks, and all the funky subatomic particles, behave. There's just one small issue. They don't get along, like at all. When you try to combine these two theories, the math basically sets itself on fire and runs screaming into the void. Something isn't adding up. That's where string theory comes in. What even is string theory? Okay, imagine you're at a concert and you're listening to a guitar player absolutely shredding. They pluck a string, and depending on how fast that string vibrates, it makes a different sound. String theory says that at the smallest level, everything in the universe works the same way. Instead of tiny, point-like particles, everything is actually made of tiny, vibrating strings, each one playing a different note. The type of vibration determines what kind of particle it is. A quark, one kind of vibration. An electron, another, even forces, gravity, electromagnetism, the nuclear forces, all of them might just be different vibrations of these strings. Essentially, the entire universe is a cosmic symphony, and everything you know is just part of a song. Wait, so the universe is made of music? Kinda, yeah. But also, no. See, there's a catch, several actually. First off, if string theory is true, then we don't just live in a universe with 3 dimensions of space and 1 of time. Nope. Turns out we need at least 10 dimensions to make the math work. 10, which means 6 extra dimensions are just hiding somewhere. Maybe they're curled up so small we can't see them. Or maybe they exist in ways our puny human brains can't comprehend. Either way, if string theory is real, the universe is a lot weirder than we thought. And it gets even stranger. String theory doesn't just predict regular old strings. It also predicts brains, short for membranes, which could be higher dimensional objects floating around in space-time. Some versions of string theory even suggest that our entire universe could be a 3D brain inside a much larger, multi-dimensional reality. Think of it like a soap bubble floating in a much bigger cosmic bathtub. So yeah, if this is starting to sound more like sci-fi than science, welcome to the club. But does it actually mean anything? Good question. String theory is beautiful, elegant, and solves a lot of problems. But there's one slight issue. We can't prove it, at least not yet. Since strings are way, way smaller than anything we can currently detect, we have no way of testing if they actually exist. Like right now, string theory is more of a mathematical framework than a proven scientific theory. It's like a giant, intricate puzzle that seems to fit together perfectly, but we don't have the final piece. But if it's true, it could be the theory of everything, the one equation that finally unites the big and the small, gravity and quantum mechanics, Einstein and Schrödinger, the ultimate cheat code to the universe, and that's just the beginning. Because if string theory is right, it means reality is a lot stranger than we ever imagined. Alright, so we've got these tiny vibrating strings making up everything in the universe. Cool. But here's a fun question. How often do these strings actually show up in reality? Like, do we just stumble upon them in the wild? Not really. If string theory is correct, these little guys are everywhere, but they're so small that we don't even notice them. And I mean small. How small? Imagine an atom. Pretty tiny, right? Now zoom into the nucleus, and inside that, you've got protons and neutrons. Still big compared to what we're looking for. Go even deeper, to the level of quarks, the little dudes that make up protons. All right, now multiply that tiny size by about 100 billion, and then you get to string theory's fundamental strings. At this scale, calling them small is like calling the sun a little warm. The cool part? These strings aren't just sitting there doing nothing. They're vibrating, constantly. And the way they vibrate determines what kind of particle they become. A photon? That's a string vibrating one way. An electron? That's a different vibration. Gravity? Yup, yet another vibration. Essentially, everything in the universe is just music. But instead of a guitar or a piano, we've got tiny quantum strings jamming out the laws of physics. But hold on, if everything is just vibrations, why don't we see weird new particles all the time? That's because the frequency of these vibrations has to be just right, like hitting the exact notes in a song. Some vibrations match up with particles we know about, while others, they might exist in ways we haven't even detected yet. Which brings us to a problem. See, for string theory to actually work, it needs more than just our regular 3 dimensions of space and 1 dimension of time. It needs at least 10 dimensions, 3 we can see, plus 7 more, that are curled up so tiny that we don't notice them. You can think of these extra dimensions like tiny loops at every single point in space. They're there, but we can't interact with them in any obvious way. And this is where things get weird. Some physicists think these extra dimensions might explain why fundamental forces, like gravity, are so much weaker than they should be. Maybe gravity isn't actually weak. Maybe it's just leaking into these extra dimensions. The idea of hidden, unseen layers of reality has fascinated humans for centuries. From ancient myths about hidden realms to modern-day sci-fi, people have always wondered if there's more to existence than we can see. And if string theory is right, there definitely is. So if string theory is real, how do we prove it? Can we just look at strings under a microscope? Nope. Remember, they're way too tiny. But physicists have a few tricks up their sleeves. One method is looking at particle collisions, like the ones happening at the Large Hadron Collider. If extra dimensions exist, certain particles might disappear into them, leaving behind weird energy signatures. Another idea? Cosmic strings. These are theoretical massive strings stretching across space, relics from the early universe. If they exist, they might be detectable through their gravitational effects. Basically, physicists are out here hunting for the tiniest, weirdest clues that might prove string theory right or wrong. At the end of the day, string theory is still a theory. We don't have solid proof yet, but if it turns out to be true, it changes everything. It means that everything, galaxies, black holes, you, me, that weird noise your fridge makes, is all connected through vibrating, microscopic strings. It means the universe isn't just a chaotic mess of particles, it's a cosmic symphony. You're part of the music. Anyhow, universe this, string theory that, all I know for certain is that we're here. And since we're here, would you be a part of my string theory? Hit that subscribe button so we can all be tiny, vibrating strings in the YouTube dimension. Okay, enough nerd talk. But seriously, like subscribe, comment, it would really help me out in the long run. So to conclude, what do you think about this? At the end of the day, it's all theories. But do you think it's true? What's your take? Tell me in the comments. I read every single one. Until next time. Bye-bye.